So previous lecture we discussed about the aeration, and in that we discussed about the what is a principle of aeration and what is the basic purpose of aeration. So the principle of aeration, it is nothing but simply the gas transfer. Okay, so gas transfer, it is a principle of aeration, and what are the different purpose and advantages of aeration? So purpose of aeration, it is nothing but to absorb the more oxygen from that atmosphere, also to prevent or to release the unpleasant odor and gases from the water, and also to oxidize the Fe and Mg from that water. So these are the some of the purpose of aeration and advantages. Again, the similar advantages of aeration. It oxidizes organic matter. It removes some bacteria. It removes CO2. It removes H2S, and also it oxidizes Fe and Mg from that water. Okay, and it also releases the bad odor from that water. Okay, so these are the various advantages of that aeration process. And after that we discuss about the various methods which are used for the aeration process. So the cascade aerator, or also you can say the steps aerator, where the 3 to 4 steps are used for that aeration process, and water is allowed freely follow that steps. So water is come in contact with the air, and atmospheric air that going to be add, or oxygen is going to be added into that water, and the bad gases which are released from that water. Okay, so that is a cascade aerator, which consists 3 to 4 steps, metallic steps. Next one is a spray aerator, where the spray nozzles are used, and at a pressure with the 0 point pressure of 0.07 to 0.14 Newton per mm square, that pressure is utilized to sprinkle the water through the nozzle, and the height between 2 meter to 2.5 meter. So after that we discuss about the diffuse aerator, where the diffuser plates are used at the bottom of the tank. Okay, and the compressed air is used at the bottom, which supply the compressed air through that plate, and which release the bubble into that water, and that increase the oxygen into that water. So that process is called as air diffusion method. Okay, so now, what is a mechanical aeration, or what is that exactly diffuse aeration? Okay, so it is a superior mixing with a full depth mixing for any depth. Okay, because why? Because air is supplied from that bottom of the tank, so completely the mixing of air into that water, it may be 2 meter or 3 meter depth. So completely mixing throughout the depth is carried out by the diffuse aeration system. Okay, so full basin utilization, a limitation of mixing depth, limited energy, and this is the superior mixing in case of diffuse aerator. Major energy saving, 40% of energy, and also the capital cost if you use deep basin, very economical. So these are the mechanical aeration or diffuse aeration. So this process, diffuse aeration process, having some of the advantages. So what are the advantages of diffuse aeration system? The first one is the high oxygen transfer rate. Okay, so instead the dissolve of atmospheric oxygen, if you are going to use the air diffusion process, so that the rate of oxygen transfer is too much high in case of diffuse aeration process. So the first one is a high oxygen transfer rate in diffuse aeration. Next, simple installation. Okay, so the process of installation of that diffuse aeration process is very simple. You have to fit that diffuser plate at the bottom of that your tank, and that which supply the air from that bottom. Next, lower energy cost. So it can be operated at a lower energy cost, capable of being connected to both round and square pipes. Okay, so fully flooded pipes made with eco-friendly polypropylene, and available in usable length for up to 2 meters. Okay, so these are the various advantages of diffuse aeration system. Okay, so as its name is diffuse, the pipe which fitted at the bottom of the tank, and which is in diffuse condition, so that process is called as diffuse aeration process. Next, the common operating problems of this aeration process. So some of the various problems that occurs during this process. So that is, the first one is supersaturation, which may cause corrosion of air binding in filters. Next, slow removal of hydrogen sulfide. The process of the removal of hydrogen sulfide is slow. Next, algae production, clogging the filters, and overuse of energy. So these are the various advantages of this system. So these are the disadvantage, you can say. So these are the common operating problems which occurs in this diffusion process. Okay. So we require some operational testing in this process. And what are that operational testing? So basically, these three basic control tests are involved in the operation of aeration process. The first one is dissolved oxygen. So we need to check how much amount of dissolved oxygen is present into that water, because higher the dissolved oxygen, that leads the corrosion. Okay. Next one is pH. As the pH going to be increases, that also we have to check what is the pH for that water, and the temperature also going to be checked. So these three parameters we require to check to control the test. Okay, DO, dissolved oxygen, pH, and the temperature. So this process, aeration process, having some limitations. So what are the limitations of this aeration process? So the limitations of aeration process is nothing but aeration methods cannot remove 100% of CO2. So this is the first limitation of aeration process. So it is not removed up to 100% of CO2, and some of the residue is always present. A small quantity of CO2 is always present into the water. Okay, so that is the first limitation, that aeration method cannot remove 100% of CO2. Next, excessive aeration leads to the excessive absorption of oxygen. Okay, so if we are doing the excessive aeration, and that leads the excessive absorption of oxygen, and which leads the property of corrosiveness water. Okay, so if increase the oxygen content, that increase the corrosiveness of water, and that again we required or we need the de-aeration process. So that de-aeration process, it is nothing but the removal of oxygen from that water. Okay, so if the oxygen quantity is going to be increases, it needs removal of oxygen from that water, and that process is a de-aeration process, and that is a costly process. So we require to maintain the aeration oxygen content into that water. So this is also one of the disadvantage of this process of aeration. Okay, so next point, if you are considering the design of this aeration fountain, like cascade aerator. Okay, so various points to be considered in the design of aeration fountain and design of cascade aerator. So what point should be considered during the design of this aeration system? The first one is design flow, that is nothing but a discharge. So Q, it is a discharge, that is a design flow is considered in a design of aeration system. Second point, to find and assume the suitable loading rate. So we have to find out what is the loading rate for that particular aeration fountain. It is how much, 0.04 meter square per meter cube per hour, or what is the exactly. Okay, so how much the loading rate, or what is the suitable loading rate, that we have to find out. Okay, to find or to assume the suitable loading rate for that particular fountain. Next, to determine the area required for the aeration fountain. So how much area that required for that aeration process or aeration fountain, that we need to determine. Next, to determine the inner and outer diameter for a circular type aeration fountain. Okay, so if we are going to use circular aeration fountain like a cascade aerator, so in that case we require to find out the diameter of that aeration fountain. So inner diameter and outer diameter. So this both diameter we require to determine in case of cascade aerator. Next, to determine the size of collecting channel outside the aeration fountain. And next, finally, to find out area of aeration which required to adopt the suitable velocity. So these are the various points to be considered in the design of cascade aerator and aeration fountain. Okay, so this all about the aeration process. Okay, so aeration process, it is nothing but the principle of aeration process is the gas transfer. Okay, what is the purpose? To absorb more oxygen, to prevent the odor and gases, to oxidize Fe and Mg, to oxidize organic matter, and to remove all CO2 and H2S gases from that water. Okay, and it is having a various process or methods of aeration, like a cascade aerator, then a diffuse aerator, then steps aerator. Also one of the method which is used is called a trickling bed method, where 3 to 4 beds are used and water is allowed to pass through that beds. So bed like a coke, bed like a sand, and other bed you can use Okay, sand grain, sand grain that you can also use, coke you can also use, and broken slag you can use. And water is allowed to pass through that bed of sand, bed of coke, and bed of broken slag. And finally, you get the removal of gases from that water at the end. And that is the method. That method is called as the trickling beds method. So this method also you can use for the aeration process. Okay, and the next one is limitation of aeration process. So limitation is that it method cannot remove 100% of CO2, and excessive aeration that absorb the more oxygen and that required deaeration process, because maximum the oxygen that increase the properties of corrosiveness. And finally, the design. So the design which required various points to be considered: a design flow, discharge, assume the suitable loading rate, determine the area for aeration fountain. We require to determine area of inner and outer diameter of circular fountain, determine size of collecting channel, and to find the aeration louder by adopting suitable velocity. So this is all about the aeration process.